Warm greetings on behalf of Hindustan College of Engineering and Technology. This is Uma, Assistant Professor from Department of Information Technology. In this video lecture, we are going to see about name-based classification algorithm with a numerical example. Let us move on to the slide. Name-based classification is an example for supervised classification algorithm under machine learning. This algorithm works with the concept of probabilistic classification, and it is used to analyze, process and categorize the data based upon the input. The inputs are independently classified and it is used to predict the output based upon the probability. Examples of this naive-based classification are email spam filtration, sentiment analysis, and classifying the articles in a blog. The importance of this algorithm is the features of the input data doesn't depend upon each other. Each feature of the data is considered as an important feature and it will be given importance to categorize the data. And it focuses on the Bayes theorem said to be probability of A by B is equal to probability of B by A dot the probability of A divided by probability of B. This is the significance of this algorithm. Say for example, if I have a fruit or apple which is of red color and which has a weight of around 30 grams and it looks like an oval shape, then all these three features are important to predict whether the fruit is an apple or an orange. If I have an orange fruit, it looks like orange color. It will be a kind of spherical shape and it will weigh about 20 to 30 grams. All these three features are very important to predict whether it is an apple or an orange. So all these three features are independent on each other. Only I can predict the fruit based upon all these three categories. This is said to be an independent feature of Naïve's property. And we have a probability feature based upon the Bayes theorem. On the combination of this naive and Bayes concept, we are going to use the naive-based classification for supervised machine learning algorithms. Here we are going to look into an example to play tennis based upon certain conditions. I have the labeled features as weather, temperature, humidity and strength of the wind. Based upon these labels, I am going to predict to play a tennis on a particular day with the following feature said to be if the outlook is sunny, if the temperature is cool, if the humidity is high and if the wind is strong, can I able to play tennis or not on a particular day. This is what my task and I need to find this based upon the name-based classification algorithm. Let us look into the steps for solving out this problem. We are going to see this naive-based classification in three different stages. One is training phase, then the next is learning phase, and the third is the test phase. The data will be trained based upon the given data set. And during the second phase, based upon the given training data, it will learn what is the data is about. It will categorize the data based upon some conditions said to be probabilistic conditions. Since this naive-based classification problem focuses on the concept of probability, this learns the data based upon the probability of the input data. Based upon the learning phase, based upon the knowledge gained after the learning phase, the knowledge is given to the test data. The test data, by applying the knowledge gained in the learning phase, it will predict the output for the given instance. Hope you understood the concept behind the steps of naive-based classification. Now let us move on to the first stage of the problem. Here I have set of 14 days of data from day 1 to day 14 under the label outlook, temperature, humidity and wind. If the outlook is sunny, temperature is hot, humidity is high, wind is weak, there is no option to play tennis. Coming to day 8, if the outlook is sunny, temperature is mild, humidity is high, wind is weak, I couldn't play tennis. Whereas if the outlook is rain, temperature is mild, humidity is normal, wind is weak, yes, I can play tennis. This is said to be the set of training examples. Based upon this training examples, I have to learn the raw input and I need to predict some possible probabilities. Coming to the learning phase of this problem, totally out of 14 days, the probability to play tennis is 9 and the probability not to play tennis is 5. So I need to categorize the probability based upon these four features: outlook, temperature, humidity and wind. Under outlook, I have three features said to be sunny, overcast and rain. The probability to play is on sunny days is 2 by 9 and the probability of playing is during the overcast days is 4 by 9. Similarly, during the rainy days is 3 by 9. Similarly, when the feature of a temperature is called, I have a probability not to play is 2 by 5 and during mild days it is 2 by 5, during cold days it is 1 by 5. Similarly, I need to find the probability of all the features present over here. Sunny day, overcast day, rain day. Similarly, when the humidity is high normal, what is the probability to play? What is the probability not to play? Similarly, in windy day, strong and weak, how many days you can go for play option? How many days you can opt not to play? So I am finding all the possible probabilities given from the given input data. This is said to be learning phase. A raw input is given. From the raw input, if based upon the probability, the system has learned something and it has some predicted in output. This predicted probability is applied to the new instance for this problem. Let us see that in the next phase. Moving on to the test phase, here I am supposed to find out whether to play tennis or not with a particular given data. When the outlook is sunny, temperature is cool, humidity is high, wind is strong, can I able to play tennis or not? Based upon the learning data, I am finding the probability to play tennis and not to play tennis with the following features. So the probability to play tennis when the outlook is sunny, temperature is cool and humidity is high, wind is strong is 2 by 9, 3 by 9, 3 by 9, 3 by 9 respectively. Similarly, the probability not to play tennis on the particular feature when the outlook is sunny, temperature is cool, humidity is high, wind is strong is 3 by 5, 1 by 5, 4 by 5 and 3 by 5. Let us see how it is mapped to the given instance and we shall predict whether the output of the particular day is to play or not. In the next slide. Based upon the Bayes rule, the probability of playing a tennis on a particular day is said to be 0.0053. Similarly, the probability not to play tennis is 0.0206. From this predicted result, 0.0053 is less than 0.0026. From the given fact, I am predicting that 0.0053 is less than 0.0206. So we label that the given instance predicts that we cannot play tennis on that particular day with the given instance. I am concluding that the probability of S on the given data is less than the probability of no on the given instance. So we label that the new instance which is given in this problem predicts that we couldn't play tennis on the particular day. This is what the result of this Naïve-based classification algorithm using machine learning. Hope you understood the concept of Naïve-based classification, one of the supervised machine learning technique. Thank you for your patience listening.